Hello again. Welcome back. We're going to continue our discussion of communication and navigation systems, moving into the area of antennas. Antenna installation. One of the things that you'll be expected to know is that many of the antennas, particularly the vertical antennas, are not sufficient unless they also have a ground plane. And the ground plane doesn't necessarily mean it's actually an attachment to the antenna, but it is ordinarily the surface of the aircraft that the antenna utilizes to be able to fulfill its function. You can see there's a quarter wave from the height of the antenna, the wave symbol over the 4 means 1/4 wave, and the ground plane should extend the same distance, 1/4 of the wave, or in effect the same height. It should be at least that much across for the aircraft. Just mounting the antenna to the metal skin of the aircraft provides the ground plane for most antennas. And there are situations where the antenna is mounted on fabric or a composite surface. If that's the case, a metal plate is substituted, or at least put in place, so you're in effect mimicking the aircraft skin or the metal skin. The metal plate must also have a bonding or a grounding wire installed to provide a return path to the primary ground plane. So you don't just put a hunk of metal in the middle. You also have to ground that to the actual airframe structure, which might be what this illustration is showing us here. Antennas are referred to by way of their polarity, usually vertical or horizontal. They somewhat follow the orientation of the antenna themselves, so that the vertical antennas are generally sticking up or sticking down, but they're in a vertical configuration, and horizontal, similar to the horizon, they're the opposite, more of an east-west orientation, or north-south, not north-south, but east-west. Probably not the best analogy. Note that nearly all aviation antennas are vertically polarized, with the exception of the VOR and the 3 different parts of the ILS system, the localizer, glide slope, and marker beacons, which, if you recall the way those antennas look like, the VOR localizer is probably not the easiest one to see, but I think we'll get into it a little bit further in this list, but they're usually the cat whiskers or the towel bar, but it's more of a horizontal orientation. The glide slope, that was that tongue that was sticking out, and that's definitely horizontal. And the marker beacons were just little fairing strips on the aircraft itself, also horizontal. And everything else is a little whip or a pole with a ball, which are more vertically polarized. Here's an example of the antenna that's mounted up or down, and it is vertically polarized, and you can see the waves that are created or received are more of the it's like a donut that is surrounding the antenna. So a vertically polarized antenna is omnidirectional. That means it receives a signal equally well from all directions and transmits a signal similarly. Vertically polarized Marconi, that's the type that is up and down, and it normally requires a ground plane. And so this is the radiation pattern, omnidirectional. As opposed to horizontally polarized, if the antenna is laying flat, it's not really showing the antenna in this illustration, but the donut is on its side. So it's not going to receive a signal equally in all directions. It's going to be strongest when the station is on either side and perpendicular to the antenna. Its strength will be the least for a signal from a transmitter in line with its length. GPS, pretty much part of our day-to-day nomenclature. We have GPS on our smartphones. You have GPS receivers that can be purchased, TomToms or Garmin GPSs, if they're not already pre-installed in your automobile. It's also taken over navigation systems of choice for both military and civilian aircraft in America and worldwide. GPS is a satellite-based system that uses a network of 24 satellites placed into orbit by the U.S. Three components. Then the first part is the space segment, the satellite constellation. The other part is the control segment, which is the ground monitoring stations, shown here, number 2. And number 3 would be the actual user, in this case, aircraft, number 3. For accurate navigation, the aircraft must be able to communicate with at least 4 different satellites. GPS, there's also weather radar. I think they're showing these in order of importance as far as navigation is concerned. Weather radar, it is something that transmits ahead of the aircraft, because that's usually where you want to see where the weather is coming from, or what the weather that you are approaching. It's a fan-shaped PPI scope, commonly used for weather radar. Nice illustrations here. The components here, you can see the antenna. We have one in the lab. Storm scope, very similar, but it's mostly just detecting lightning. They've long figured out that an ADF radio, automatic distance finder, or I'm sorry, direction finder, would home in on a thunderstorm as well as on a conventional radio transmitter. So not only do you get signals from the ground station, but you also get signals from the lightning. The principle is made use of in the storm scope lightning detector system, and that basically works the same as the ADF. Loop and sense antennas are used. In a single unit, a computer and processor, and a small diameter visual display. When the unit is turned on, it picks up on the static electricity discharges from within the storm and shows each discharge on the display as a small green dot. Here's an illustration of a variety of antennas. The VOR toggle bar, I mentioned that before, usually at the top of the vertical stabilizer. Or it could also be the V type, the cat whiskers. High frequency wire is usually just a wire that's strung. And marker beacons are the little fairing additions to the fuselage. Loop and sense antennas are shown at the bottom. The weather radar is probably the most recognizable up here. There's two of them. They mostly look like the yellowish one. SATCOM antennas. That's satellite communication, so you can imagine that the satellites are above the aircraft at all times, so the antenna will be mounted on the top of the aircraft. There's a variety of designs, and I don't believe any questions on it. How do you install the antenna? It's a nice illustration. The black outer skin is shown, and in this case they're also using a doubler, which is bent so that you can kind of see the additional structural support that is added. It's added on the inside of the outer skin, and it's basically to provide some additional structural support instead of just the skin, because the wind forces are going to start bending the actual metal. Talking about the ground plane again, that's with the Marconi quarter wave. A ground plane is also, they also refer to it as a counterpoise. And they list the ones that use the Marconi, mostly for communication, VHF, but also for transponders, which is a kind of a communication. Distance measuring, and another UHF communicator. When you're installing an antenna, they'll usually provide a template. So you put the template down, you draw your draw right on the surface and line up each of the holes and mark where those are so that they can be drilled. In this case, the template is also showing you use the number 18 drill. It shows where the center line of the aircraft is. And there's a larger hole, mostly to accommodate the coaxial cable. A doubler, we talked about that. That is usually a A&P type project. It is riveted, and it's a nice project to show rivet spacing between each other and from the edge, and the proper number of rivets to actually use. So doublers are a favorite of professors to use as a project. Fuselage skin, the doubler itself is aluminum clad. Alright, there's existing stringers, and the doubler is actually attached right to the stringers so that it holds it nice and firm. Another showing of what the doubler is. This might be close to something that you might see that comes with the antenna, to show you an example of how the doubler, or at least where it should be located. Install the antenna on the fuselage, making sure the mounting bolts are tightened firmly against the reinforcing doubler, and the mast is drawn tight against the gasket. If you're not using a gasket, which in the illustration here there is use of gaskets, but if you're not using a gasket, there is a sealant that can be used, and we're showing that aviation gasket sealant. Where our antenna is located, this one's showing us a bunch. The VOR, we already know that that's at the top of the vertical stabilizer. We know that there's a few that are on the top. As a matter of fact, you'll see the VHF communication 1 is on the top, but 2 and 3 are on the bottom. Air traffic control, that's usually a signal to the ground. Distance measuring, also a signal to the ground, to the DME station or the DME VOR. In the radome, we already saw the glide slope, the little tongue sticking out. That's also where the radar antenna is located. Question: an aircraft antenna installation must be grounded A, to the airframe, B, to the radio rack, or C, to the engine. Where would you ground the antenna? Ground that to the airframe. When an antenna is installed, it should be fastened A, to the primary structure at the approximate intersection of the 3 aircraft axes. Well, there's usually only one spot if you have 3 axes, so if you've got 10 antennas, you're going to have trouble putting all 10 at that exact spot on the aircraft. So not A. B, with a reinforcing doubler on each side of the aircraft skin. Not a terrible answer, but usually the doubler is on the inside of the aircraft skin. Or C, so that the loads imposed are transmitted to the aircraft structure. The best answer. So that is the one that you want to concentrate on. So C. Doublers are used when antennas are installed too. Why do we use doublers? Is it A, to prevent oil canning of the skin? B, to eliminate antenna vibration? Or C, to reinstate the structural strength of the aircraft skin? And the reason we use doublers is to reinstate the structural strength of the aircraft skin. Doesn't really help with vibration or the oil canning, meaning the skin is being compressed and expanded. Doublers have nothing to do with that. So a reinforcing doubler of sufficient thickness to reinforce the skin should be used. What characteristics of the installation of a rigid antenna on a vertical stabilizer should be evaluated? Okay, you're going to put one up on the vertical stabilizer. What are you going to be mostly concerned about? Polarization and impedance? B, flutter and vibration? Or C, impedance and interference? All right, well, impedance is a resistance term for AC. Since it is in both of the wrong answers, we can almost automatically go to B. But if you do think of the vertical stabilizer, there's going to be a lot of flutter and vibration in that area. So you're going to want to evaluate the antenna installation for flutter and vibration B. And that is in the second AC. And you'll find a lot of your information about loads in the maintenance AC part 2, which is more for alterations. A gasket or sealant is used between the antenna mast and fuselage skin. Why do we use that? We didn't really say why, did we? Was it for aircraft pressurization only? Or so if you don't have a pressurized aircraft, do you need to use gasket and sealant? No, you still use it. So at only, whenever there's an absolute answer like that, you can normally, unless it's spot on, you can normally discount it. B, to prevent the entry of moisture, which is normally what gaskets and sealants are used for. Or C, to prevent abrasion between the antenna mast and the fuselage skin. It might do that, but that is not the reason you're actually installing a gasket or a sealant. You want to keep that moisture out. B. And it's a suitable sealer such as the zinc chromate paste, which we saw in one of the prior slides. A lot of these are common sense. The addition of avionics and associated antenna systems forward of the CG limit will affect, a little tricky question you have to think about a little bit, but you're adding, let's say you're adding an extra radio just for simplicity and an additional antenna, and you're putting that, both of them towards the front of the aircraft so that it's forward of the CG limit. So what's that going to do? Or what's that going to affect? A, CG limits and useful load. B, useful load and maximum gross weight. Or C, empty weight and useful load. All right, whenever you're adding equipment to an aircraft, that's automatically going to affect your empty weight. Because if you're weighing the aircraft, you're not going to be removing that additional radio. So the empty weight of the aircraft is going to be increased. And so far, empty weight is only in option C, so I like that. And of course, if your aircraft empty weight is a little higher, but you have a maximum weight that you can carry when you're fully loaded, if you add 40 pounds of antenna, that's going to be 40 pounds less of cargo that you can handle. So useful load is in effect, how much cargo can I load? It's not really cargo, it's a combination of a number of items. Fuel, passengers, luggage, and cargo. So I like C, without actually going into too much of the other two. All right, wrapped up another one. Okay, good having you, and we'll continue on. I have another one on antennas, so you might as well play that one right after this one. All right, see you in a bit.